Good day, everyone. I am Ma'am Chris, and welcome to my video presentation for my teaching demonstration. Today, I will be presenting a grade 9 science lesson on the topic of photosynthesis. Using a student-centered, engaging pedagogical approach, the inquiry-based learning or IBL. Inquiry-based learning is a teaching method that places students at the heart of the learning process. Rather than simply receiving information, students are encouraged to explore, question, investigate, and discover concepts through real-world experiences. This approach not only promotes a deeper understanding of scientific ideas, but also helps students develop essential creative or sensory skills like critical thinking, collaboration, and communication. To guide this lesson, I used the 5 E's model of inquiry-based learning, which includes engage, to spark curiosity and activate prior knowledge; explore, where students investigate and gather data through hands-on activities; explain, where learners build scientific understanding through reflection and discussion; collaborate, to apply knowledge in new and meaningful contexts; and lastly, evaluate, to assess understanding through reflection and assessment. This structured approach ensures that students are not just passive learners, but active participants in constructing their own understanding. Let's now take a look at how this approach comes to life in our lesson on photosynthesis. The class starts with a teacher introducing the learning objectives of today's discussion. At the end of the lesson, students will be able to explain what photosynthesis is, perform a simple experiment demonstrating oxygen release during photosynthesis, and record observations accurately. And lastly, appreciate the importance of photosynthesis in our daily lives. For the first part of 5E's model, which is the engage, a short time-lapse video of plant growing is presented via multimedia presentation. The multimedia presentation is used to capture students' interest, activate prior knowledge, and visually introduce complex concepts like photosynthesis. It supports different learning styles, encourages inquiry and discussion, and helps make learning more engaging and memorable. After presenting the time-lapse video, the teacher asked these questions. Where do plants get their food? Can plants survive without sunlight?
Plants produce their own food through a process called photosynthesis.
Okay, thank you. Where do plants get their food?
Plants get their food primarily from the sun.
Okay, thank you.
Plants need sunlight through photosynthesis.
Okay, thank you.
No, because plants need sunlight so they cannot survive for a extended period of time.
Okay, thank you. The purpose of asking these questions after showing the time-lapse video is to stimulate curiosity and get students thinking critically, activate prior knowledge about plant growth and energy sources, guide inquiry by setting up the central questions of the lesson, and lastly, encourage prediction and hypothesis, which are key components of inquiry-based learning. These questions help students connect the visual to the scientific concept of photosynthesis, setting the stage for exploration and discovery. In the second part of 5E's model, which is the explore, the students are engaged in hands-on activity entitled Bubble Hunt, Catching Photosynthesis in Action. The students are divided into groups. In this hands-on experiment, students will work on groups to observe the process of photosynthesis in real time. Each group sets up two plant samples, typically using scented leaves submerged in water under a glass funnel and beaker. One setup is placed under direct sunlight, while the other is covered with a black garbage bag to block light. As the leaves photosynthesize, they release oxygen, which appears as bubbles. Students will count and record the number of bubbles produced every 30 seconds over a span of 3 minutes. The collected data will be used to compare the result between the light and dark conditions. The activity helps students see the release of oxygen as proof that photosynthesis is taking place. By comparing the two setups, students discover that light is necessary for photosynthesis to occur effectively. Students will actively observe, record, and analyze real-time data, fostering critical thinking and experimentation skills. Working in groups allows students to communicate, delegate tasks, and learn collaboratively, which is the core goals of inquiry-based learning. Instead of just reading about photosynthesis, students experience the process through inquiry and discovery, making the concept more concrete and meaningful. The activity enhances skills like data interpretation, graphing, and drawing evidence-based conclusions, all within an engaging and interactive context. After the activity, the teacher selects a student representative from one of the groups to present their group's graphs. The selected students explain the data collected during the experiment, highlighting the difference in the number of oxygen bubbles produced by the leaves exposed to sunlight versus those kept in the shade.
After our experiment, we found out that exposed leaf produces more bubbles compared to covered leaf, as it is exposed to sunlight and the heat of the sun affects also has its own effects to the production of bubbles. So in conclusion, more the number of bubbles produced in exposed leaf is greater than the covered leaf. And that will be all.
Okay, thank you. Following the presentation, the teacher facilitates a class discussion by asking guided questions such as, what did you observe in the test tube placed under sunlight compared to the one in the shaded area? Through students' responses, it becomes evident that the setup exposed to sunlight produced a significantly higher number of bubbles, while the shaded setup produced fewer or none at all. The teacher then connects this observation to the scientific concept of photosynthesis, emphasizing that the presence of light is essential for the process to occur efficiently. The teacher briefly explains that sunlight provides the energy necessary for plants to convert carbon dioxide and water into glucose, which serves as their food. As a result, oxygen is released as a byproduct. This explanation is supported by introducing the balanced chemical equation for photosynthesis. This equation summarizes the process by which plants synthesize their own food using light energy and reinforces the role of sunlight as a key factor in enabling the transformation of raw materials into glucose and oxygen. The class discussion and the visual representation of the experiment helps solidify students' understanding of the relationship between light intensity and the rate of photosynthesis. To deepen their understanding and apply what they have learned, students will remain in their original groups and select one of the following differentiated activities based on their preferred learning style or group strengths. These tasks are designed to reinforce key concepts of photosynthesis while promoting creativity, critical thinking, and collaboration. Each group will then present their output to the class, allowing for peer learning and constructive feedback. These are the differentiated activities. First, for the visual learners, they will design an infographic or concept map that clearly illustrates the inputs, processes, and outputs of photosynthesis. Include key factors that affect the rate of photosynthesis, such as light intensity, carbon dioxide concentration, and temperature.
Plants have green pigments called chlorophyll stored in the chloroplast. This pigment aids in capturing light energy from the sun that enables plants to change it into chemical energy stored in the heat. This process is called photosynthesis. In order for photosynthesis to occur, the plants need carbon dioxide plus water with the aid of sunlight, and then it will produce glucose and oxygen. Okay, thank you.
For verbal linguistic learners, compose a short poem or spoken word piece that captures the significance of photosynthesis in sustaining life on Earth. Emphasize how it contributes to the oxygen supply, food production, and balance in ecosystems.
So, they build our food, release our air, a gift they give with silent care. Without their life force ultimate, no life would bloom on land or sea. So praise the leaf, the stem, the sun, for through their bond all life is one.
Logical mathematical learners interpret a given data set that shows the rate photosynthesis under varying light intensities and create a simple graph identify observable patterns or trends and write a brief analytical explanation connecting the data to scientific concepts.
So good day everyone. So we have been given a data set where light intensity and rate of photosynthesis. So then we translated it into a line chart. So as you can see, as light increases, where until it goes between 4.4 or like 80 to 100, where light is not a limiting factor yet. So as you can see, ganun.
This differentiated task allows students to demonstrate their understanding in meaningful and personalized ways, fostering engagement and inclusivity while encouraging deeper exploration of the topic. To consolidate their learning and assess their understanding, students will engage in both reflective discussion and a brief formative assessment. Group reflection, the student will participate in a guided reflection by responding to the question, what can you conclude about the effects of light on photosynthesis? This reflection encourages students to synthesize the result of their experiment and connect them to scientific concepts discussed. It also reinforces the idea that light is a crucial factor in the rate and occurrence of photosynthesis.
As light increases, plants make more oxygen, meaning photosynthesis speeds up. But after a certain point, this doesn't even.
For the short quiz, student will complete a quiz that asks them to identify the raw materials and products of photosynthesis. This includes recognizing that carbon dioxide and water are the raw materials, while glucose and oxygen are the products. The purpose of this phase is to evaluate students' conceptual understanding of photosynthesis, provide an opportunity for self-assessment and reflection, identify misconceptions and reinforce correct scientific thinking, and gather feedback for the teacher to inform future instruction and support. Here are some of the students' feedback after engaging in inquiry-based learning.
I prefer this kind of lesson because the experiment showed me the difference of the covered leaf and the exposed leaf, which really showed me the importance of sunlight in photosynthesis.
After the discussion, it taught me the value of on-hand personal exposure to scientific materials such as beakers and test tubes. And the lesson also teach me how crucial photosynthesis is in our environment and how it affects the food cycle and life cycle of of life.
Okay, thank you. Wow.
So I think for my reflection is like this method of teaching, like having an on-hand experience of the lesson, makes it better for us to understand rather than having long hours of lectures na hindi kami nakaka-hands-on. So I think this method of teaching is better.
Okay, thank you.
In conclusion, the use of inquiry-based learning through the 5 Is model has provided students with meaningful and engaging way to explore the process of photosynthesis. By actively investigating real-life phenomena, collaborating with peers, and reflecting on their observations, students not only deepen their understanding of scientific concepts but also develop essential skills such as critical thinking, problem solving, and communication. This approach fosters curiosity, encourages exploration, and transforms the classroom into a space for discovery, where learning becomes both purposeful and memorable.